All right, now I'm recording. I will re-talk about that now. Just quickly. So right skewed, pulling the mean to the right, the tail's on the right. Left skewed, pulling the mean to the left, the tail's on the left. Symmetric is the mean and median are exactly the same. What I was going to say before that is I wrote the test. So if it's something that I haven't talked about in class, it's probably not on the test. Just keep that in mind too. That's what popped into my head, and then I'm like, oh crap, I forgot to record. So yeah, just keep that in mind. I don't have, my tests aren't written from the book. Like I took problems from the book, but I chose the problems I was going to take. So, all right, this is another one. This one that is really obvious, but it's not something that's talked about a lot. And it is something we're going to talk about a little bit more when we do the box and whisker plots a little bit later. Range. The range of the data is the maximum value minus the minimum value. Like I said, it seems pretty obvious. It's one of those things that just makes sense, but it's not one of those things that are often talked about. Range can come into play when you're starting to look at how data is spread, which is some of the things that we're going to start talking about with standard deviation. We're looking at how much information is spread apart. Range is one of those values that tells us that because it's just the maximum and the minimum. Right? All right. So I am going to show you, I'm going to do this. You are not going to do this, but I'm going to do this because I want you to understand what standard deviation is. And then I'm going to show you how to actually just do it online. Okay. So you are not going to ever have to do what I'm about to show you how to do. Okay. But it's one of those things that by doing it out, you'll have a better understanding of what standard deviation means and how it works. So you'll understand how to do it. And then when the number you get, why that number either makes sense or doesn't make sense. Because one of the biggest things that people need to know about when they're using a calculator, calculators can give you any answer in the world. If you don't type in the right information, you're not going to get the right answer. And I've had quite a few times because this is what the calculator gave me. I'm like, yeah, but it makes no sense because they typed in something wrong. It's like, I need you to be able to look at that answer in the calculator or whatever website you're getting and go, this answer makes sense. I understand what it means. Okay. So that's what I'm going to go through and show you here. Standard deviation is designed to tell you it's a way to determine spread. So if I have data that's all really clumped together in the middle, my standard deviation is going to be very low. Okay? Because all the information is pretty close together. If I have information that's really spread out, my standard deviation will be quite large. So, for example, if I was going to look at the ages in this room, okay, the majority of you are pretty close to the same age, probably 20s, maybe early 30s, for the majority of you. So my standard deviation might be pretty small, all right, might be a pretty lower number there. If I add in the few people that are a little older, that might make that standard deviation a little bit larger. Because now my data is a little more spread. My range is a little more spread. Okay? So that's where you have to start looking at what standard deviation means. So now let's look at how you actually calculate. The first thing we need to figure out for standard deviation is what is the mean? Because we're looking for that middle number. Okay? So in this problem, we've got 72. Right for me. There we go. 73, 76, 76, and 78. So it's a pretty small set of numbers. So how am I going to find out my mean of this one? How am I going to figure out my average? Add them all up, and I'm going to divide by 5. All right. I remember I don't trust you guys with calculating things for me. So I'm going to do it.
Might not remember that.
So I'm going to do it myself one time.
All
right. Here's your check of chance. What's 375 divided by 5? All right. So my mean is 75. So that U symbol, so that stands for mean. So whenever you see that symbol, that's the mean of your data. Okay? It's like almost like a cursive U. If I remember right, it's the Greek letter mu. But so it's that cursive style U. That stands for mean. So whenever you see that, you're going to think of mean. All right. Now, if I'm going to look at spread, I want to know how far the numbers that I have are away from that mean. So I'm going to take each of these numbers, and now you're going to figure out really quickly why I'm never going to make you do this out by hand, because it takes time. So we're going to take each of these numbers and we're going to subtract from the mean. So I have 72 minus 75, 73 minus 75, 76 minus 75, 76 minus 75, and 78 minus 75. So I've got -3, -2, 1, 1, and 3. Okay. Not even close to done. The next thing I'm going to do is I'm going to square them all. Because negative numbers would be bad, so they square them. So I've got 9, 4, 1, 1, and 9. All right. So my standard deviation symbol is that. It's like a O with a tail on it. All right. That's the symbol for standard deviation. So I'm going to add all the numbers I just squared. So 18, 19, 20, 24. And then I'm going to divide by one less than I had. So I had 5 numbers. It's 5 minus 1. So I'm dividing this by 4. So my standard deviation is the square root of 6, which is approximately 2.45. So that's the standard deviation of this. Is it better with the white, or do you want me to add more colors? Okay. Okay. That was the one thing that helped one of my other students. So it's like I wanted to make. I can add more colors. It's fine. All right. So the standard deviation of this one is 2.45. That means that the spread is 2.45. Now we're going to talk more about what standard deviation means when we start looking at the graphs. We'll be actually kind of soon. So you can start to see like this is a lot of work for just 5 numbers. If I made this 10, 20, 30 numbers, you have to do the same thing. Okay, so there's no way I'm making you do that on my. All right, so let me see if I can find a site really quickly. I've been using Symbolab, which I kind of like. Yes, so this is one that I've been using that has a lot of stuff in it. This is called Symbolab. Symbolab.com. It has, you can sign in. It has a paid version, but I'm not signed in right now. So this is just the free version. And it's got all the pre-algebra, algebra, pre-calculus, calculus functions. And then over the statistics, one of the options is standard deviation. So you can just click that. And we're going to type in the numbers. So it was what? 73, 72, 72, 73, 76, 77, 76, 72, 73, 76, 76, and 78. Just put the numbers in there with commas between them and hit go. And there's my standard deviation. Okay, so notice they did the same formula I just did. They got the variance is 6, which is the number that we got into the square root. And the square root is 2.4. Okay, that's how I want you to do it. All right. So if I'm asking, and there is a question on the test that asks you to find standard deviation, that's what I'm expecting you to do. So that being said, I'm not taking your phones. Okay. I actually kind of expect you to use your phones. However, I have other ways to do this without your phones. So if I'm walking around or if I'm sensing that there's things amiss and people are using their phones for other things that which you can use for the test, we're going to have issues. And I'm not going to allow you to use your phones. So use it for what I'm asking you to use it for. Don't use it to cheat. And you're going to be able to continue to use it and not have to do things out by hand, which would suck. All right. So, that understood?
Yeah.
Good. Yeah, there's other websites you can use. This is just one that I happen to use that works for Symbol Lab. I don't know. So, like the paid version, if you actually click on it, it'll actually show you like what all the steps and stuff are. So it'll actually walk you through it. So like if you're trying to learn things, it's actually not a bad site to go through and look at how the steps and stuff work out. Not for this, because you're not going to have to do it out, but for some of the algebras and stuff like that, it's actually kind of useful to learn how to do some of those things. So I'm working on writing a book and I use the site literally because it does all the steps out for me. So it's like I do it out and I use the site to check all my work to make sure all my numbers are right. Because obviously, unlike all the books that I've ever used in my entire career that I find mistakes in constantly, I don't want mine to have mistakes in it. So it's like I go through and use this to check them all out. So, all right. So that's standard deviation. That's how you would find standard deviation. And that's how I'd expect you guys to find standard deviation in here. Okay. Now, what does standard deviation mean? That's what we're going to look at next. So, there's two rules that we're going to look at. Mathematicians like to name things after themselves. I do not expect you to remember the names of the rules. However, like in the test, one of the questions actually says use this rule. He's Russian. I think it's Chebanovsky or I honestly couldn't tell you. One of the things I was never good at was names.
I know. Had to be
It's a Russian rule in mathematics. That's what we're going to go with. All right. So, what we want, so standard deviation is designed to tell me how far data is from the mean or the median. Remember, if it's normalized data, the mean and median are exactly the same. So what we kind of want to know is how much data is there. Okay. And I know last class I kind of briefly showed you a bell curve, and I'm like, there's like 68% here, 95 and 99. That's known as the empirical rule. That's where typically data falls if it's in a normal distribution and a nice bell curve. What this rule does, this rule works kind of for any data. All right, even if it's not a normal distribution. But it just gives us a baseline. It doesn't give us an exact type of value. Okay. So what he did was he says, for any data set, no matter what it is, we can find out approximately how much data is within one standard deviation, 2, 3, 4, however many standard deviations away from the mean I want. So when he did one standard deviation, if you did 1 minus, well, sorry, you have to use 2. 1 doesn't work because the digits there. So 1 minus the 2, he says at least 75% of his data will be there. Because if you do 1 minus 1/4, that's 3/4, right? So 3/4 is 0.75, 75%. He's not saying exactly 75% of the data is within 2 standard deviations. He's saying at least 75% of the data should be within 2 standard deviations away from the mean. So in the last problem, my mean was 75, correct? Okay. And my standard deviation was 2.5. So if I go 2 out, that would be 5. So he's saying at least 75% of the data, 75% of the players will be between 70 inches tall and 80 inches tall. Because that's 2 standard deviations away. Does that make sense? Okay. Let me show you. So we've got my means here. And we're going to round my standard deviation to 2.5. So it's 2.5 because I don't feel like dealing with 2.45, all those other numbers. So 2.5. So 1 standard deviation. So if I go out 1, I would add 2.5 and I'd subtract 2.5. So I'm now at 72.5 and 77.5. Okay. So within 1 standard deviation of this, using the data we got, players should be between 72.5 and 77.5 inches tall. If I went out 2 standard deviations, so that was 1. If I go out 2 standard deviations, now I'm going to do 2 times 2.5. So I'm going to minus 5, and I'm going to add 5. So now I'm at 80 and 70. Okay. So out of 2 standard deviations, I now have all players are going to be between 70 and 80 inches tall. Okay. Now, if we look at our data, all our players are between that, right? Because we only had 5 players. The more data we have, the better that our information is going to be. So we only had 5 players, and they're all between that. So 100% of my data is within 2 standard deviations. Actually, I think 100. Nope, not 100% because there were 78. So his rule stated that at least 75% of the data will be within 2 standard deviations. Our data shows that 100% was, but it's at least 75, which is all that it says. Okay. If he went out another standard deviation, so if we added so it was 7.5 on the other side, we get a 3rd standard deviation. His rule says 89%, at least 89% of all the data will be within 3 standard deviations of the mean. So yes,
I'm just a little bit lost.
That's fine.
But we say the first one that at least 75%.
Yep.
Is that?
It's 2. It's not the first one. It's actually 2 standard deviations.
Okay.
The first one doesn't work.
You just have each of the the standard deviation 2.5.
Yep.
Do they just go to each side of it?
Yeah, you're gonna add it to both. So like the first one here.
2 more on the same. Okay.
Correct. Yeah. So this one was, I went 1 standard deviation was 72.5 to 77.5.
Okay.
My second one is I do another 2.5 on either side.
Okay.
And that's how I get to the 70.
And that's always 89%?
Yeah, at least 89% would be 3 standard deviations. Another one out actually would be 3 standard deviations. So this is the first one, this is the second one, and I didn't do the 3rd one on this one. Because we were already at 100% of our data for this one.
Well, if you were to do another one, would that be at least what?
It would be at least 89%. So if I did another one, just going out, because I'm going to run out of space. So 3, I'd be minusing 7.5. So I'd be at 67.5. And this way, I'd be adding 7.5, and I'd be at 82.5. So at least 89% of the players would be between 67.5 and 82.5. Okay? This is a nice rule when you're looking at data that's not normalized. That's not in that nice bell curve. So if you have data that's jumbled, you can still do standard deviation. If you don't have enough data, you can still do standard deviation. This rule still kind of works for that. So let's look at this one because we're actually going to use this rule. All right, so in this problem, it gives us two pieces of information, which is the two pieces of information you're typically going to need. It gives us this data was looking at forearm length at 140 men. So we looked at the forearm length of 140 men. The mean is 18.8, and the standard deviation is 1.12. Okay? So those are the two pieces of information they gave us. So now, they said, apply Chebyshev rule of 2 to make pertinent statements about forearm lengths in men. So the first thing I'm going to do is let's actually do out the curve or the standard deviations out to 3. So we can start seeing what they are going to be all the way out to 3. So my mean is 18.8. I'm going to add or minus 1.12 and add 1.12. So it's 18.8 plus 1.12. 1992. And minus 1.12 would be 1768. Yes? Somebody with a calculator? I don't feel like taking my phone back out of my pocket. I'm trusting you guys again. Okay. All right. That's one standard deviation. Now let's do 2 standard deviations.
What percentage is in one?
His rule doesn't work because it's 0. Because the way his rule's set up. The empirical rule, which we're going to talk about in a little bit, has something for one. So 2 standard deviations, I'm going to add another 1.12. And I'm going to subtract another 1.12. So now I'm at 21.04. Yep. And 1646. 56? 56. Okay. Oh, that's right, because it didn't jump over. All right. So now we know. So if we apply Chebyshev's rule, Chebyshev's, I think that's how you pronounce it. 2 standard deviations was 75%, right? Okay. So that right there, from there to there, is 75%. So if we were going to make a statement about this data, we can say that 75% of all men, okay, because we took a sample, and then when we're making statements, we're going to generalize that statement. That's the entire purpose of taking a smaller sample, to get information that we can then generalize. So we're going to say that 75% of all men, or at least 75% of all men, have a forearm length between 16.56 and 21.04 inches. Okay, that's what his rule allows us to say. So at least 75% of all men have a forearm length between 16.56 and 21.04 inches in length. If we go out one more, again, we're going to add the 1.12 and we're going to subtract the 1.12. So we got 22.16 and 1544. So now this is 89%. Now we're at 3 standard deviations. So at least 89% of all men would have between a 14.44 inches and a 22.16 inch forearm. Okay. Yeah, 22. What did I say? Oh yeah, 22.16. All right, so that's what his rule allows us to do. Okay. So now we were talking last time I talked about the door, right? When we start looking at the further out, you're not going to design things for a very small percentage of the population. You're going to design things for the majority of the population. So if we're at least 89% at this point, you're starting to get towards that majority. So if I'm going to make dress shirts and sleeve lengths, I'm going to probably make the majority of my sleeves between the 15.44 and the 22.16, because that's going to hit the majority of all men. So that's where you can start to see how this stuff is being used to then make decisions about products and commercials and advertising and all this other stuff. Okay. Yes.
The K3 just how many go out?
Yeah, it's how many standard deviations you're at. Yeah. He's using K for his number and his formula to determine how far you're going out. So, all right. Does that make sense? Okay. All right. The empirical rule. You are rarely going to use Chebyshev's rule. You are almost exclusively going to use this rule. So one of the things we're going to see later on as we start making these curves and doing some more data analysis and stuff is that once you get past, as long as you do your data collection properly, once you get past about 30 to 50 people when you're collecting data, or 30 to 50 data points, it will pretty much fall into a nice bell curve. Okay? It's just the way nature works. It's like it literally will start to fall into that nice bell curve. And if not, go back and look at your data to see maybe the way you're asking a question or something else is off in that point. But almost exclusively, it's going to start falling into that nice bell curve. Because of that, we can do some calculations on that. All these calculations, has anybody in here taken calculus? Because they're actually sometimes you can take them for statistics. If any of you ever actually do end up taking calculus, you actually can calculate out that this is all calculated with calculus to figure out that area underneath the curve. It's actually integration from calculus. So that's where this came from. So all these numbers that I'm going to give you, there actually is ways to calculate them out. They make your life simple in statistics. They actually give you ways to do it out without having to do the massive calculus work. I have two classes. So, the empirical rule, and this is what I mentioned last week we were talking about. One standard deviation away from the mean is approximately 68% of all data. Okay? So we're going to talk about this, and then I'll bring the curve over and we'll blow that up so you can see that a little bit better. 68% of all the observations and all the data points will be within one standard deviation of the mean. So at that point, we're already at a majority. We're at a majority of people literally within one standard deviation. 2 standard deviations away from the mean, you'll have about 95% of all the data points. Okay? But 95% of all the data points will be within 2 standard deviations of the mean. So the Russian guy's formula said it was going to be at least 75%, right? Mm-hmm. Does this still qualify for that? Is 95% at least 75? Yes. It's well above 75. His rule says it's at least 75. It has to be bigger than that. 95 qualifies. Okay? So it's just a lot more accurate representation of that from that bell curve. But his data works without a bell curve. That's why we still have to look at that one, because there is situations where you don't get a nice bell curve. The third level, 3 steps out, so 3 standard deviations, is 99.7% of all your data. So this is where I was talking about the door heights. If we get up to 3 standard deviations, if I set the door height at 80 inches, which is 3 standard deviations away from the average height of a male, I'm going to have 1 out of every 1,000 people at this. So there's no point in me going higher. Okay. All right. So You'll hear this talked about a lot as the 66, 68, 95, 99.7 rule. It's just the three numbers. Okay. You're going to see that quite often. And if you look online for bell curve 68, 95, 99.7, you're going to find this rule and they're going to talk about it. All right. Let's look at the bell curve. I'll rewrite the numbers on it just because I really want this as big as I can get it. All right. That is a normal bell curve. Okay. My mean or my median, remember in a normal bell curve, this is symmetrical. My mean and my median are exactly the same or assumed to be the same. So they're right in the middle. One standard deviation out, two, and then three. So one standard deviation out. So if we look at just this section right here, that right there is 68%. So 68% of all of my data will be right between those two lines there. Okay. Hold on one second. I want to say one thing. Okay. Yep. Just wanted to make sure that the problem afterwards is exactly the same problem we're doing here. All right. If I go out one more standard deviation, so if I fill in this section here and this section here, we are now at, so from, I'm going to put the 95 over here, but just because I'm going to run out of room. So that's from there to there. That's the 95%. And then if I fill in this and this, that's 97%. Okay. Oh, sorry, not 97%. 99.7%. I was like, wait a second, that's not 99%. All right. And if you go out again, you can keep going. It's like 99.9999%. So in essence, after you get past three standard deviations, you're basically at 100%. It's just going to keep going out and getting closer and closer to the perfect thing. So if I remember right, so IQ, the median IQ is 100. Okay. The standard deviation for IQ is 10. Okay. So when you have people keep telling you, I'm in the 99th percentile and everything else for IQ, or I've got an IQ of 170 or 180, like all these things. So if it's 100, 110, 120, 130. So 99.9 or 99.85% of all people have an IQ under 130. Okay. So the odds that you know multiple people that have an IQ higher than 130 are slim. Okay. So it's one of those things. It's statistics in that case. It's like it's the hard numbers. It's just what it is. Everybody always thinks they're a lot smarter than they actually are. So it's like same thing with heights and stuff like that. It's like average. Most people are average. It's like I know we like to all think we're special and everything else, but most people, most things about you are pretty average, right? 68% of the people are right around average. A little above, a little below, but nothing drastic. Okay. So nothing wrong with being average. All right. There we go. So this way the notes are still there and the picture is still there. It works. All right. Okay. We're going to look at the same data that we just did with Chebyshev's rule. Okay. And actually, since I don't want to have to rewrite this, we're going to do this. And I'm going to cheat. All right. So we now know with the empirical rule that from here to here is 68%. From here to here is 95%. And from here to there is 99.7%. Because we've taken 140 people to do this, and again, what I said was, remember, most things in nature fall into the nice bell curve. We can make an assumption that this data will fall into a bell curve because we have so many data points that we can get a lot more accurate understanding, and including what one standard deviation is, because the rule doesn't tell us that. So within one standard deviation, so 68% of all men have an average forearm length between 17.68 and 19.92. 95% have between 16.56 and 21.04. And 99.7 are between 15.44 and 26.16. So where his rule said at least 89% was, this rule saying it's probably closer to 99.7, which means there's no real reason for me to make sure it's that shorter than that or longer than that. Okay? If you want that, go into you get to get a custom shirt at that point. So all your shirts are between there and there. Okay. Does that make sense? That's the point of standard deviation. Okay. That's that when we were calculating out that number and coming up with the 2.45 for that other set, or in this case, the 1.12, is that's designed to tell me how far the numbers are spread. If my data was a lot wider or a lot more spread, these numbers would be a lot bigger. But the rule, the 68 to 95 and the 99.7, remains the same. Okay? The spread might be different, but the rule stays the same. All right? So you don't have to go through and do the calculations out to find those things out. Well, how many of you are in the bank? Still free. When the hallway goes dark. All right. So I have 14 slides for this for chapter 3. I'm on slide 10. That just goes to show you how little there was really in chapter 3. It covers, like, it talks a lot and stuff like that, but I'm literally, these are the main things that you need to get out of it. There's not really, they make it a lot more complicated than it has to be sometimes. All right, so the next thing we're going to talk about, so we've got the bell curve, and we're going to spend a ton, the majority of statistics is built around the bell curve. So we're going to spend a ton of time dealing with the bell curve. This is just a nice little introduction to the bell curve. The next thing we're going to talk about, though, is the famous box and whisker plot. So if you've ever gone to the doctor and they tell you you're in the 95th percentile, or so, how old's your baby?
She's 17 months.
Okay, when if you don't mind me asking, you can tell me. You can say no. I don't want. I'm not going to. When you first went to the doctor, like when they were like 2 or 4 months, and the doctor checked their weight, they told you what percentile. Did they tell you what percentile they were in?
She was a preemie, so she was very, very little. She was in like 1%.
Okay, so the funny thing, it's like, I'm sorry, she was a preemie, but
No, it's okay.
The- so I'm glad she's got that, and she's running around golf courses, so it's great. So and I hear this from like even teachers. Like teachers you think would be smart and understand this stuff and that, but I've been around teachers for years, and the women all come and it's like, oh, baby, they're in the 95th percentile in the weight and 95th percentile in height, and I'm like, you realize that's bad, right? That means they're overweight and tall. You really want 50. But nobody wants to keep. It's like, oh, they're getting. It's like, no, that means they're way on the other end. I know I'm totally in like the 95th or 96th percentile of weight. But that's the thing. Is like people think, oh, these numbers are great.
That's what my doctor said. I think she will catch up, right? She's like, she's fine. She's not fat.
Yeah, it's like, yeah, you can always feed them more. It's hard to go the other direction. Yeah, it's like you can always feed them a little more and she'll grow in and stuff like that, especially at that age. But yeah, you don't want to be up there. Like maybe in height and stuff like that, you can be a little tall and stuff like that. We glorize like big, tall, like taller people and stuff like that, but you don't want to be there, especially in weight. It's like that's not where you want to be. So the quartiles or percentiles, which is quartiles are just literally 4 of them instead of every one of them. Are the same concept, that it's telling you what percent of people are below you. Okay, so a box and whisker plot, or even these, is designed around quartiles, where it's splitting into 4 equal parts. Okay, those parts do not need to be the same size. Okay, they need to be the same number of data points. Right, so when we make our box and whisker plot, you're going to see what that means. Right, and actually, you can even see, like if it's uniform, they're pretty much straightforward. A bell shape, but even this, like 25% of your data here, 25% of your data here, 25 here, 25 here. Notice those lines do not correspond to standard deviation, because if it was standard deviation, that would have been 68% in there. Okay, so they're a little closer. They don't completely connect to each other. Right skew, same thing. 25, 25, 25, 25. They're all the same. But the number of data points in each of these is 25% of them. So quartiles really is based around median more than mean, because median splits my data in half. All right, because that's the middle number. So half of my data is on either side of it. And then if I find the middle number of each of those, I can split them in half again. And I have 4 pieces, which is in essence what we're going to do. So the first quartile, or actually the second quartile, is your median. That's the number right in the middle of all your data points. So 50%, 50%. You typically do not call it the second quartile. You call it the median. The 2 that you're going to hear, first quartile and third quartile, those are the medians of the bottom half, is the first. And the upper half is the third. You don't have a fourth quartile because that's your maximum. And you don't have a lower one because that's your minimum. So you just have first, second, and third, because if you make 3 cuts, you can always cut things into 4 pieces. Okay. We're going to go out. We're going to do this so you can see exactly how it all works. All right. So Nielsen interviewed or sampled 20 people, and they were weekly viewing times in hours. So this is the number of hours that people watched television. And I think today, if they looked at this and added in other media, it'd be way higher than what it is now. People spend a ton of time literally just surfing on their phones. All right, so what's the first thing I've got to do to this? What's the first thing I got to do to this data before I can even find medians and all this other stuff? Huh? I've got 20 of them. So I know exactly how many I have. Yeah, I have to organize. I have to put them in order. All right, so the very first thing I'm going to do is put them in order. And because I'm not going to have enough room to sit there and write them out like in one straight line, I'm going to do 10 and 10, which is going to work out nice for my little thing anyway. So we've got 5. Let me not use highlighter. 5, 15, 16. So 5, 16, 15, 20, 21, 2, 3, 4, 5, 25, 8, 25, 26, and
You write
27.
the same number twice.
Yes. So if the same number appears twice, you have to write it twice. 30?
30.
2 30s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's make sure we cross those off. So 16, 20, 21, 26, 25, 27, 30, and 30. Okay, so we're doing good so far. All right, next set. So we got 31, 32 twice, 34, 35, 38 twice. Then we got 41 and 66. And that's 10 more. Okay. All right. So we've organized all the numbers. Good job. Hardest part of the day. All right. So now, because I'm not going to have enough room on here to do what I need to do, and I'm not rewriting these. I amazed Brian Kennedy by doing this when he was observing me one time. It's like, how? That's like, yeah, pretty good at manipulating computers nowadays. All right, so we've got our numbers. Okay, so now we want to break this up and find our quartiles. Okay, so first thing I need to find is my median. So how do I find my median? No, you do you do not have to do this. Actually, believe it or not, once you put them in order, going online is probably harder than looking at it yourself. Because you literally have to retype all the numbers in again.
Oh, yeah.
So median is the middle number. I have got 20 of these, right? Okay. So because I have 20, I'm going to have two middle numbers. I'm going to have my 10th number and my 11th number. Those will be the two middle numbers. Okay. Because if you were thinking, like if you were going to sit there and cross them out, you cross back and you have two numbers left in the middle. So my median is 30 and 31. So I'm going to do 30 plus 31 divided by 2, which comes out to be 30.5. So that's my median. Okay. All right. Any questions with how I found that? Good. Next, we're going to find our first quartile. My first quartile, I'm going to look at the first half of the numbers. So in this case, I'm going to look at the first 10 numbers. And again, I'm going to do the median of those numbers. So I've got 10, so I'm going to pick the fifth and sixth number. So 1, 2, 3, 4, 5. So 21 and 25. So again, I'm going to add them up and divide by 2. So I got 46. So that'd be 23. This is my first quartile. The third quartile. Remember, we already found the second quartile. That was my median. The third quartile, I'm going to do the same thing. So the upper half of the numbers. So we're going to look at the fifth and sixth numbers. 1, 2, 3, 4, 5. So 35 and 38. So again, going to add them up, divide by 2. You do not always have to add them up and divide by 2. It just happens to be these are all even numbers. If you had an odd set of numbers, it was just the number that's in the middle. So we've got 73, so 36.5.
Yes.
Okay. All right. So we now have our first quartile, our median, our second quartile, and our third quartile. If I'm going to make this a box and whisker plot, which I have at the end here, but we're going to start to make it, I need 2 more pieces of information. I need my minimum, which in this case is 5, and I need my maximum, which in this case is 66. Okay. All right. Questions with that? Everybody see how I got those numbers? Okay. We're not going to make my box and whisker plot yet, because there's one more thing we got to figure out first. It was the one thing I said at the beginning. I says, we'll talk about that later. Anybody remember? It was outliers. And I said, there's a very specific definition of an outlier. This is the very specific definition of an outlier. All right. So, when we're creating our box and whisker plot, we have an upper limit and a lower limit. Okay? If a number is outside of that upper limit and lower limit, it is considered to be an outlier. Okay? That upper limit and lower limit is 1.5 times whatever the interquartile range is. Now, we have to figure out what interquartile range is. Really simple, actually. What's range? Max and min, right? Okay, so if I'm going to think about interquartile range, going back to this, which 2 numbers do you think I'm going to use? Right, we're going to use the quartiles. We're going to look at 36.5 and 23. Those are the 2 numbers I'm going to use. Okay? So my IQR is 36.5 minus 23, which is 13.5. That's my interquartile range. Okay. So my lower limit is 23.23 minus 1.5 times 13.5. Interquartile range. It's just Q3 minus Q1. I probably should write that on it because that's actually not written anywhere on here. There you go. So 1.5 times 13.5 minus 23. So this comes out to be 2.75. My upper limit is 36.5 plus 1.5 times 13.5. And that gives me 56.75. Yes.
So that means that's the line that you go to. That's where the stops.
Yes. So typically, up until if you did this in middle school or high school or wherever else, you wouldn't have done this. Your lower whisker is your minimum, your upper whisker is your maximum. Okay. Because we have to get a little more sophisticated and a little more information on it and understand how outliers could really affect the data, we need to look at the outlier. So your lower, your little whisker will either be the minimum or the lower limit, whichever one happens to be lower. Or no, whichever one happens to be the highest one. So like if I don't have any outliers, it's going to be my minimum. My upper one is going to be where it is or the maximum, whichever one would come first. Does that make sense?
So it just, lower limit will be 5.
So in this case, my lower limit is going to be 5. Yeah. My minimum is still going to match for that because I don't have an outlier. However, my upper one is going to be the 56.75, and then I'm going to have an outlier at 66. Okay. Does it make sense being able to figure out my upper limit and my lower limit? Yes. So in this situation, if we look at this data, I have one outlier. I have a 66 as my outlier. Okay. And you would think with all this copying and pasting, I would have actually copied the just nice plot of this, and I did not. So while you guys are looking at this, I'm going to go get the nice graph of it because I don't feel like drawing it. Because I know it's in the book. Yeah, unfortunately the online one isn't on page 430. Yeah, which is fine. It's just I found it. Oh, I was wrong actually. All right. That on the next page. I'll leave that big. All right. Okay. I was wrong. So when you do instead of the 66, because that's an outlier, my max line is going to be at 43. It's not the upper limit. So there's our max and whisker plot. We have our median is at 30, approximately. It was 30, was it 30? Yeah, 30.5. We have our Q3, which is at 36.5 per rate. Our Q1, which is at 23. We have our minimum, which was at 5. We have our maximum, not including our outlier, which is at 43. And then we have our outliers at 66. So what this shows is that there's 25% of all the data in each of those sections. So there's 25 data points down here. There's 25 data points in here. There's 25 data points in here. And there's 25 minus 1 data points in there. And then that one. Okay. So each of those sections have the exact same number of data points. All right. So this is just another way to look at spread. Okay. We can look at how the data is spread, how it's clustered into certain areas. So, but the box contains 50% of all your data points. And that's chapter 3. So, all right. Take like a 10-minute break. I am going to have to turn on the lights because you're going to have to be able to look at the actual questions on the test and write stuff down. So I will turn on the lights. So yeah, take about a 15-minute break. I don't know. I think the caft's probably open so you can get to the vending machines and stuff. I don't think the kitchen part's open. So it might be. I don't. You can go down and look. I was like, I know the vending area is open. All right, close your eyes. I know. It's, all right, I'm gonna have. There's just no way. I'm gonna have to stop one. Oh, this one.
Yeah.
Okay, that's better. I didn't have a stapler, so. And they are double sided. There's one problem per page, so it's not. Don't freak out because it's 5 pages.
How many problems are on there?
Like I said, there's multiple parts because of the way it asks it. So yeah,
So you're
I love it.
down a little bit.
this is the test. Start.
That's it.
All that things about me being nice. Nah.
This.
I got a stapler, I carry with me every day.
Oh, thank you.
I bring it everywhere.
Sweet.
Never know when you're gonna use it.
Yeah, she has a stapler. Thank you.
I'm coming, I carry it everywhere. I always need it.
It's like I printed them all at home and I don't have a stapler at home, so I brought it to school today. And the stapler I had at school was out of staples.
We can have fun.
So I'm like,
I'm trying to keep it property.
yeah.
Thank you. Oh, sorry.
It's like my stapler was at school, my staples are at home. All right. I will be right back.
I think. Yeah, you did.
We're going to try to find coffee. Yeah, we're gonna take, because I don't know where the cafeteria is. Is it open?
I have absolutely no clue. We're gonna go
I
check.
don't think
I
it
don't
is.
think it's open.
I was gonna try to jump in the car to Dunkin', like,
The actual cafeteria part where they serve food isn't open, but
like coffee and stuff.
the
You know, to the cost.
the actual like dining area cafeteria is open with the vending.
Thank you, Michelle.
Podcast.
The running machines are open, but the actual.
Do they have one of the coffee machines that they do?
Do you want a pen?
I got that.
Okay.
Oh, it's all right.
I have extra pencils.
Oh, thank you. I'll go ahead and say those.
We're gonna go have a storm, like the week of the day. But, okay, so I should get up for forget. Yeah.
Damn.
All right. Everybody should have gotten a copy of the test. I think I put one wherever saw like there was stuff. If you did not get a copy of the test, I have more up here. So. And if after you do your notes out, if you'd like an extra copy of the test, I do still have a few left, so it'll be first come for like whoever gets up here first to snag one. All right. So 10 questions. The ones on the actual tests are pretty similar. I actually think I made the ones on the actual test. There's a couple problems with like a bunch of numbers in them. The ones on the actual test I think have less numbers in them just because you have to physically do it out by hand, like some of it by hand. So I figured this one you're practicing. So if it's a little longer, it's not going to be that big of a deal. You will have the entire next class period or next Tuesday to do it. So as soon as you're done with your test, you can go. Okay. So that's how we're going to deal with that. So this way, because there's no point making you wait around for half hour, 45 minutes for people to finish the test and stuff like that and come back and do stuff. So as soon as you're done with the test, you can go. I'll be here. I can't get in here early, so the class will start at 6. I tried to get here early, but there's another class in here. So it is what it is. But you'll have the till 8:45 to finish the test. And honestly, it should not take you that long. It really should. We're going to do it tonight in like probably just over an hour. So, and that's with me explaining things. So it shouldn't be too bad. All right. So the first question is from chapter 1. We're looking at terminology and principles of experimental design. Okay. I did not take a ton. So like I tried to mix up the thing. So it's like they're in order. So the beginning is chapter 1, the end's chapter 3. It's like it is in order of how it shows up in the book. So, and it will stay in that order. I'm not going to mix them up on you. So, all right. So what's an experimental unit? And everybody has the question, so you don't necessarily have to look at the board to read the thing. So what's an experimental unit? Well, yeah, you can give me this one or tell me in general. So, yeah, this one, the experimental units would be the. So, yeah, the experimental units are the individual items on which the experiment is being performed. So, actually, hold on a second. Let me read this one. Richard had shown handed a bottle, showed how to open it, and left it alone. Actually, this one, the experimental units, is the bottle. The bottles is what you're actually testing. Yeah. The bottle is actually the experimental unit. I would say your subjects are the children, because your children are the ones who are actually doing it. But the units that you're actually testing in this situation are the bottles. Huh? Yeah, you got the right bottle. On the yeah, you got the right. Yeah, don't try to. Oh no. So these are 5. These are it's not multiple choice. There's 5 questions. That's what I said. So I almost never do multiple choice. I hate multiple choice with a passion. And multiple choice tests, if they're written right, are a pain in the butt to write. So you will rarely ever see multiple choice questions. There might be multiple pieces to them, but again, I'm looking at it in terms of a question. So when I'm looking at this, I'm expecting each question, like even with the multiple parts, to take you a certain amount of time as a question. All right. So if there's multiple parts to it, it's not necessarily just to make the test longer. It's just because that's the way that question was done to give you those points. So, like these 5 questions, these 5 things don't take that long to do, even though it's 5 parts for one question. Response variable. Exactly. Is the bottle open or closed? So the response variable is the characteristics of experimental outcome that is to be measured or observed. So in this case, it's opened or not. What's the factor? Yeah, the different types of bottle, right? Right. Yeah, possible factors is open or not. Yeah. So what's the treatment? So each experimental condition for one, the treatments are the level of a single factor. So actually I think in this one, it also is just open or not.
Yeah. That's a bundle. So if it's just a binary, it's
Yeah.
a bundle.
Yeah. Because so your levels, the way we have to actually describe, if you wrote it out in a sentence, you could say, we're trying to determine, like, for your fact, the levels of each is, are you trying to determine how, like, the bottle's opened? Or they're telling you it doesn't matter how fast they did it, as long as they opened it within 10 minutes, no matter how they opened it, it's not childproof. So even if they smashed it, it's like it's still technically not a childproof bottle. So that would be the levels of the treatments is open or not in that situation. That's question 1. And I gave you an entire page to do each question. That does not mean you necessarily need the entire page to do each question. It was just simpler that way than not. And it's also how I grade the tests. So when I'm going through and doing my scoring, I do not score your test as a whole. Like when I'm going through, well, okay, let me rephrase this. When I grade it question by question. So I will grade everybody's question 1 and then everybody's question 2. Okay. So I won't grade your entire test and then go to the other person's. This way, when I'm grading the questions, I'm consistent in grading that question. So I'm looking for that one question. This is what I expect. I'm going through grading everybody's question 1. So I'm more consistent with that. So this way, basically after the first page, I have no clue whose paper it is. So that's how I do my grading. So if you email me on Friday saying, you're going to take the test on Monday. If you email me Tuesday morning and ask me what my test grade is, I'm probably not going to have it. It takes me a little bit because I go through, I have to grade basically everybody's test before I know anybody's grade. Okay. I do make mistakes. It does happen. I am human. So if for some reason after you get your test back, you say something's wrong here, I think I got this one right, just tell me. We'll look at it. I'm not the type of person to say, no, I never make mistakes. I definitely make mistakes. And you're definitely okay to call me out on them because it's your grade. So, all right. This question, and because it's statistics, there's a lot of reading, unfortunately, in some of these questions. We're looking for what type of sampling design was used by these authors in the survey. Which one?
The treatment.
Did you open or not?
Oh. Wait. Why did that the treatment?
Because it was the experimental condition. So in this case, the levels, literally, there is only 2 levels.
Yeah.
It's open or it's not.
Well, I don't understand.
So, okay, so your possible values of the factor are literally all the different possible options that can happen. So like in this case, my levels and my treatments are exactly the same because there is only 2 options. So like if I'm looking at, so your levels are possible values of the factors go, like if we're talking about hair color, it could be blue, red, green, those type of things. Where the treatments are the levels of that factor. So how red are you? How green are you? How blue are you? Those type of things. That would be the different levels of that factor. In this situation, my levels are only open or closed. So there's only 2 options. And there is no in between open or closed. And that's actually the way they specifically worded it, did that because it says, for each side channel left alone, it was open within 10 minutes, even by the teeth, the bottle failed to qualify. So it's either open, it's technically, I guess you could also say it's either passed or failed, or open or closed, because it's in essence the same thing. Either the bottle is opened at the end or closed at the end. All right, so this one, I always like reading the question first and then go back and reading what the information is. So this one is asking you what type of sampling design was used by these authors in the survey. Huh? Sure.
It's about the answer. Because, all right, is cluster sampling the same as random sampling?
No. So when you're looking at sampling designs, you have, so cluster sampling, well, okay, everything has to be random. The question is what is the random piece? So you can randomly just select out of everybody. That would be completely randomized. So that'd be a random sampling. Cluster sampling is when you cluster things together. So the example we did in class was the blocks. Those were clusters. And then they randomly selected certain blocks, but then they tested or asked the question to everybody on that block. That's cluster sampling. Yeah, see, it's random how you're choosing the blocks, but the clustering, so it's not individuals piece. That's why it's that clustering part. they do it that way because it's easier. It's like if you're just going to randomly select houses out of this entire neighborhood, it's going to cost you more money to go to each individual house. By sending a person to a block and asking 20 people, you're saving time and money. So they look at that thing in terms of clustering. So it says, in this survey, 10 of the 46 schools participating in the immunization campaign were randomly chosen, and then their parents of all the non-immunized children at the 10 selected schools were sent to the questionnaire. So, now based on what I was just talking about, this would be cluster sampling. Okay? Because they had 46 schools, they randomly selected 10 schools, and then they asked everybody in those 10 schools. Okay? So this would be cluster sampling. Now, so this question, like the first question is pretty obviously it's going to ask. It's going to ask the same 5 questions. It'll just be a different thing. This question, the other question on the test, is going to ask the same thing. It's probably going to be using a different sampling method. So yes, know what cluster sampling is, but you also need to know what the other sampling procedures are. Okay, because it could be any of those sampling procedures. But the second question is going to ask about sampling procedures or the sampling design. I need the inauguration ages of the presidents.
We get this question, you have to like look up all the ages.
This is why I said this is the question you're gonna have on the test will have the numbers there for you. The list was just, huh? This list is just was too long to put on the paper. So I figured if you're gonna do it at home, it was easy to look up the numbers again. So that's why I figured that it was just gonna be an easy way to do it that way. All right, so next question. Actually, so the book question only asked for only had the first 44 presidents. So I added the 45th in this one. Because we have 45 presidents. I think the book was written before. All right, so this question really is about stem and leaf plots, making sure you understand how to make a stem and leaf plot. Okay. So when you're writing a stem and leaf plot, remember you have the bar. It's the ages, the anything except for the last digit. So in this case, we're talking about ages. So if we look at these are the ages at inauguration of the 45 presidents. So the youngest president was 42 years old. And the oldest was 78 years old. So, and actually that's 46 because technically I guess Biden was inaugurated, so I put 46 in there too, I guess. So we'd go from 4, 5, 6, 7, and that's all I would need. I don't need an 8 or higher. So those are the first digit in the ages. Okay? Oh, I suppose I should share back that tab. Forgot to switch back. Sorry, I forgot to switch back. So we've got 4, 5, and 6, and 7. So those are basically the tens.
Right.
Common range. 40, 50, 60, and 70.
50s.
Right.
But you don't write 40s, or would that be
We're-
incorrect? Or
No, so in the stem, it's just 4, 5, 6, and 7. The other side, the leaves, are going to be the other numbers.
44, 45.
Right, exactly.
That's right, yeah.
So I'm going to copy and paste this over just so we can see these.
That's right.
And then we'll just do the first one. So here is the 40s, because we don't necessarily need to do them all. There's the 40s. So if this was a stem and leaf, a one line per stem, I'm going to show you the difference between a one line per stem and a 2 lines per stem. We're just going to do the 40s though, for simplicity's sake. So here's the 40s. So my 1 is going to be 2, 3, 6, 6, 7, 7, 8, 9, 9. That's how I would write the stem and leaf for 40s. So we have 42, 43, 46, 46, 47, 47, 48, 49, and 49. That's a stem and leaf. Okay? We would do. All right, I'll slow down. So here's the 9 presidents that were inaugurated before the age of 50. Okay? So a stem, you only want one digit after the for leaves. So in this case, we're talking, these are 40, 50, 60, and 70. So that's my stem, and that's my leaf. So 42, first president. 43,
JFK.
46,
Okay.
46, 7, 47. That's how you write a stem and leaf. Okay? Was it JFK?
JFK.
Nope, it was not.
No, and I'm wrong. I thought
It was Theodore Roosevelt. JFK was 43.
Yeah, I said 43 was JFK.
Oh, 40. Okay, yeah.
When
yeah.
you said 43, it's JFK.
Gotcha. Yeah.
Because I thought he was the youngest, and I started.
Yeah, Theodore Roosevelt's the youngest.
Yeah, I would have said JFK.
I wouldn't have guessed Bill Clinton was younger than Barack Obama, honestly. I thought Barack Obama was younger than that. It's like in the last 2 presidents we've had have been the oldest presidents by a long way. So, all right. So now that is a single line per step. Okay. If I was going to do a 2 lines per stem, I would just have 2 4s. And then we're going to split it. When you split it, 5 is the number you split it with. Okay? So 0 through 4 is the first line. 5 through 9 is the second line. So I would have 2, 3, 6, 6, 7, 7, 8, 9, 9. So your first line is 0 through 4. Your second line is 5 through 9.
And what would be the reason you'd want to do that? And just having a single.
It depends on how spread out your data is. Like in this one, because a lot of them are clustered in that 5 and 6 range or 4 and 5 range, like there's 14 to 37. So there's 23 presidents between in the age of 50s. So having one line with all of them, it doesn't really help as much as maybe having them spread out a little bit more instead of doing it by 10s, do by 5s. And that's really why you might want to do it that way. So it gives you a little bit more of a progression of the data. So, and to see what's going on with it. So instead of having 4, like at 10, and then 5, and then 6, and then like 3 at 7, you'd have a more slow progression up, and you might get to see a nice bell curve or a nice curve out of it instead of having just the spike in it.
When you give us the data like that on this side, right?
Yeah.
Oh yeah, on your test, you're going to have the actual data on the test. Yeah.
That's why I'm here wondering how.
Yeah, no. So I figured when I made this test, I knew you guys were going to be able to be at home or have your phones and everything else on you. So I figured worst case, you could literally look up the president's birthday ages because I didn't want to put a list of 40. On the test, the list will be there. Yes. You will not have to search anything up on the test. It'll be on the actual test. This is, I think, the only question I did that to just because I knew it was something really simple to look up online. So, all right. But that's really that's what you're looking for. Now, I didn't do the whole thing because I didn't do the 5, 6, and 7. But that's what a 1 stem would be and what a 2 stem would be. You just have to do it for the other pieces there. Yeah. You do it for 5, you do it for 6, you do it for 7. So, and we split at 0 to 4 and 5 to 9 because there's 5 numbers in each group. Okay. Not 0 to 5, 5 to 10, because the 10 would technically be 50. So that's why we did 0 to 4 and 5 to 9. Yeah, sure. All right. Okay. Next. Okay, actually, you know what? I'm going to do. I'm just going to copy the table for this one. Screen. That's not what I wanted. All right. Actually, you know what? Because you have the numbers, I'm not even going to put the numbers on here. I'm just going to put the. I'm going to write the questions. Then we can look at those. This way. All right. So Prescott National Bank has 6 tellers available to serve customers. The data in the following table provides the number of busy tellers observed to 25 spot checks. Use single value grouping to organize these data into frequencies and relative frequency distributions. So if we're doing single value groupings, that means we're counting up exactly how many of each numbers come into play, right? So if they have 6 tellers, so I'm going to have 0, 1, 2, 3. I'm going to run out of room, so I have to do it up here. 0, 1, 2, 3, 4, 5, and 6. So frequency is literally just counting up how many of each one. So how many zeros do I have? I have 1 of those. How many ones do I have? 2. How many 2s do I have? 2. How many 3s? 4. How many 5 or 4? Sorry, how many 4s? 5 of them. How many 5s? And how many 6s? All right, let's see if you redeemed yourself from the Democrats and Republicans. 5, 10, 18, 25. Very good. All right, so that's the frequency. How do I get a relative frequency? Yep, so I'm dividing them by what? Yeah, how many I have? So 25. So I divide by 25. So I have 0.04, 0.8, 8, 1, 6, 2, 0, 2, 8, 1, 6. Okay. Yes. Yep.
You said the decimal was the round.
Yes. All right. It's asking for modality. That's literally the mode. Which one occurred most often? 5 did. All right. Is the data roughly symmetric, right skewed, or left skewed? Yes, it is left skewed. The hump is on the right, the tail is to the left. Okay. This is one of those ones you do not necessarily have to answer these questions in order, because the next question down asks you to make a dot plot. Okay? The dot plot, if you look after you look at it, you'll see the skew. So it might be better to make your dot plot first, and then you'll see your skew are built into it. Okay? So my dot plot, we have 0, 1, 2, 3, 4, 5, 6, and you're just going to put dots above them. So we have 1 there, 2 there, 2 there, 4. Oh, oh, it's okay. No, it's the light. So and I was using red, and it just was no, it's fine. I can change colors. Not big. So we've got 1 there. Actually, you know what? I'll do it this way. This should help a little bit. That better? Okay, no problem. 2 there, 4 there, 5 there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So now you can see it's left skew. So that's one of those things, like, draw it out sometimes and you can see it if you couldn't look at it just by getting the numbers. And then it said the last one, compare the dot plot you obtain in part the E to the relative frequency. Or we didn't draw the relative frequency histogram. We skipped B. Remember the histogram, it's going to look exactly the same. It's just going to be a box. So yeah, it'll look the same. I somehow I skipped that question when I was going down. I'm like, oh. So a relative frequency histogram is literally just, it's going to be the count. So in this problem, yeah, that'll be on the left. 0 through 6 will be on the bottom. And then you're just basically making bars that go up to the different boxes there. Now, I understand this is not an art class. You do not have to be perfect with it. As long as I get a general idea, you knew where you were putting the lines, we're good. Okay? As you can tell, I am not an artist. So, all right. Just kind of try to make it even as close as you can. Like when you're making your dots, like I started, I'm like, oh, let me just make them close together. I'm like, no, that would be bad because you're not going to see the height.
Right.
So it's like that's like I took like spread them out so you can get the 5. Because like this one has to be higher than this one. So when you're making it, just make sure that happens and we're good. Honestly, on this question, I'm going to look at your numbers. If your numbers are right, as long as your pictures are close, we're good. Okay, because the numbers are where you're actually calculating out what you're going to be basing your pictures on anyway. So as long as your graph looks like a histogram and like looks like it's close, we're good. As long as the dots in each line count up right, we're good. Okay. Nope. Yeah, so like on this one, I like honestly for this one, I probably would count by 0.04. Just because it's simple. I wouldn't count by 0.05 because then you're gonna have to go in the middle of them. You can go by anything you want, as long as whatever you do, you're consistent on it.
Yeah.
So like you can't go and while I'm saying that, you can't go 0.04, 0.08, 0.016, 0.020. You're gonna go by 0.04, 0.04, 0.08, 0.012, 0.016, 20, 24, 28. So this way you can't, they have to be evenly spaced, but you don't have to count by a specific number. Okay.
For the histogram.
Yep.
It said on the right-hand side, on the left-hand side going up, we use the 0, 1, 2, 3.
No. On the left going up, you're going to use your percentages. The 0, 4, 0, 08, 0, 12, or 0 in the 12. Yeah. On the bottom is the 0, 1, 2, 3, 4, 5, 6. Yes. Yes. In this case, no. So so you can draw a histogram or anything else without actually numerical values. All right. So in this case, since it's single value grouping, your groupings are 0, 1, 2, 3, 4, 5, 6. Right. You're not making it's not going over to 0. It actually is 0 there.
And then just pick the number like that is the value you want to do.
If just like put a line above it, you don't necessarily have to draw the whole bar, but so I know kind of where that you have seen. The other thing is, again, because the last one's comparing those two graphs, so your two graphs should be almost identical. That's like, so it's like that's what you're going to say. That's my two graphs look the same. So
How do you do that? How do you compare it?
you're going to have two graphs, and you're going to tell me what they look like. If these two graphs would have been exactly the same. I didn't draw my histogram. Would you like me to draw the histogram so you can see it? Okay. Always want me to do the hard work. It's fine. It's why they pay me the big bucks, right? All right, let's see. We're going to see how crappy of a job I can do on this one. I think the highest was 0.28, right? Okay, so 0 was 0.04. 1 was 0.08.
Yeah.
2 was 0.08. 3 was 16, right?
Correct.
4 was
20.
20. 5 was 28. And 6 was 20 or 16, right?
16.
There you go.
Right now.
Oh, okay, so you just make a bar graph. Okay.
So remember, a histogram and a bar graph are almost the exact same. A histogram connects. And a histogram, we can start doing the limit grouping and those type of things where you can't do that necessarily in a bar graph. So, but yes, a histogram and a bar graph are very similar.
What's the question at?
It says compare this graph to that graph. And if you eliminate the blue line, because the blue line's not going to be there, because I was just using that to show skewed, they should look, the shape of them is the same. Like 4 and 6 are basically the same height, or 3 and 6 are basically the same height. Or no, 4 and 6 basically the same height. I actually drew an extra box on. Oh no, I didn't. 3 and 6 are the same height.
3 and 6.
I'm looking at the blue numbers and I'm like, oh, yeah, 3 and 6 are the same height. And then 4 and 5 are a little bit higher, so you can see the same. It's going to look basically the same. That's what I would expect for question F. Both my graphs look identical.
Oh, right.
Yes, literally just right there. However wordy you want to make it, that's basically the gist of it. Yes. No. There you go. You're welcome.
So it's exactly the same color.
Yes. All right. Okay. So consider the data set 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the mean? What's the median? How do I find mean? Okay, so I'm going to add them all up. So yes. So my mean is 5. And then my median is also 5. All right. Now it says replace the 9 in the data set by 99 and redo it. So you have 110, 29. 129 divided by 9. Right? So 100, 10, 20. Oh, yeah, 135. Sorry. Divided by 9. It's 15. And my median is still. But yeah, so they take the 9 out and put it in 99. The goal of this question actually is less to do with finding mean and median and more for you to show me that you understand what an outlier can do to a problem. For the data set, part B, the mean is neither central, or typical. Like this one, the mean is 15, right? That's not even one of the numbers. So that 99 pulled it way to the right. The lack of what property of the mean accounts, or lack of what property for the mean accounts, or the lack of what of the property of the mean accounts for this result. So we have that outlier. That 99 is an outlier of the data and it's pulling the mean to the right. So C,
I thought I was asking you a question.
well, kind of, it's like you just have to talk about what, you just have to describe to me what happened. Okay? So that's literally what this happens. It's like, what happened to this? I will tell you this is the exact same question. I just changed the numbers and the problem.
I thought it was asking whether it was central or typical, and I think I don't know what that means, but it wasn't asking the question, it was just stating.
Yes. So it's,
I mean,
yeah, the 99, the outlier pulls the mean to the right because it's significantly higher than the other data. And this is why we don't typically use mean to talk about most situations dealing with money and stuff like that, because the outliers pull it in one direction or another. That's why Connecticut's one of the richest states in the country, because we have a bunch of billionaires that happen to live in the state. Was it in 2016 or 2017? A billionaire died in the state. And the state got a $240 million tax. Like, that was a tax bill for this estate. It like balanced the budget. It was like, it literally like gave them this massive influx of money that was like a one-time shot because this person died. So in the way the estate taxes goes, it cost them $240 million. This is why most of your rich people figure out ways to stash money in Florida that does not have an income tax. So it's like, yeah. But if you're worth tens of billions of dollars, what's $240 million after you die? It's not that big of a deal. At least I wouldn't think it's a big deal. They probably think it's a really big deal. It's a lot of money. So, yeah. So that's the age debate that we have right about now, right? That's the debate in politics right now. So, all right. So that's question 5.
So for C,
C is just literally tell me what you see happening in A and B. That the median remains the same, but with the outlier, it's pulling the mean to the right. Huh?
Your windows down.
Yeah.
As long as it's not your sunroof.
It's the
I
sunroof.
don't
Oh.
know why.
I don't know.
My wife did that when it snowed.
Oh,
I'm like, have fun. Have fun. I don't know, because it was well, yeah, she had no. My wife left it open in the winter. Yeah. Sometimes my wife's not the smartest bulb. It's like it happens sometimes. Yeah. It adds up, darn. No, I'm one of those people that you don't have to. I will tell her. I tell her. Like it's not. Like I am not. I am that type of person that is. Nope. It's like runs out of gas. I'm like, you realize it's not that hard to put gas in your car. It's like, I didn't think, yep, that's what happens. All right, next one, where I get myself in more trouble. Good thing she never listens to these recordings. All right. So the next question says, determine the range and sample standard deviation for each of the data sets. You only are going to have one. For the sample standard deviation, you will not have. So this is an easy one. Here's the numbers. Go to account computer. So here's what you're going to do right now. Find a place you're going to find me the standard deviation for this, and do it. Symbolab, which is the one I'm going to pull up in a second. So this is the site that I'm going to use. It's called Symbolab.
Oh, no. Oh, no.
Yeah, it's symbol AB. And yes, this is really old data for billionaires. It's way higher than that. Hold on. I don't know.
No, I got it. So you have to go to the statistics on the back. If you go down, go to the statistic, and then you give you more options.
You got it.
This is scan a problem.
That's what we gotta do,
Yeah.
scan the problem?
I'm like, I'm not. Hold on. Let me pull it up on my phone so I can see how it actually shows up.
Yeah, sometimes that's
Okay, but when you scan it, it says it doesn't look like anything.
Yeah, I was gonna say.
Yeah, I was gonna say you're probably not gonna be able to scan it.
Okay. You don't have the option to put it in manual.
Yes, you do.
You
Good.
do, then how do you do it? I'm doing something wrong.
Okay, so go down the very bottom, and you'll see related. If you go, okay, make sure you're on the actual home screen for Symbolab. And down the bottom, it says all these different calculators. Pick statistics. Actually, you know what? I can do it this way. Hold on. Aha. We can cheat because I can show you this.
Just download the app, but this is it.
The app, yeah, but does the app actually, it's the same concept though.
It is, yeah. It will.
Come on. Show my phone. No, you won't. There we go. All right. So, except it's not going to show all the wording on it. It's too darn bright. All right. If you scroll down to the very bottom, you'll see all the different calculators. Pick statistic calculator. And then the examples, one of them says standard deviation. And then you see it at the top, you can type your numbers up. This is why I figured test this with you. So you can find out, make sure you know how to do this today.
Download the app. It
Yeah.
does.
You sound like my high school kids. Like, just delete TikTok, you'll be fine.
I have it.
And if you can't get on the internet,
But I don't.
I'm just doing it.
Okay. so here's what I'm going to tell you to try before you come back next week. Because if you try to do it out manually, you're going to be here forever. Download the app at home, turn your phone in airplane mode, and see if it works.
Okay.
If it works, then you'll have no problem here doing it. Okay? Let's figure it.
It's easier to like lay down, they don't have to worry about how they have it.
Oh,
You just have to just go.
Oh.
It looks like, you know.
The only difference, and we're gonna get into this later on, is N minus one or one, is we're just N on the bottom. And most of the situations you're dealing with are gonna be samples, so you're gonna see that piece there. Yeah, yeah. And actually, if you hit standard deviation on it, it's gonna give you the sample one. So, most of the things, if you see standard deviation, it's gonna assume sample. It'll say population standard deviation if it wants the whole population, because it's so rare that you're gonna do the population, have all the data for the entire population to do it. You typically use sample. You should get 13, actually 13.003, so 13.
How many decimal points do you want to put?
I think that actually says 1 decimal place. So this one I get, it actually comes out to be like basically exactly 13, 13.003.
Do I put like a comma?
Yes, you have to put a comma between the numbers.
There's no comma. I know, look, you try to hold the period. No, you're, yeah, you're comma. Try to hold the period, it's a comma. It's really difficult for narration.
There are other options out there. You do not have to use this one. There is other, like if you type in standard deviation calculator into Google, it might actually even have it on Google. I just happen to use this one.
It is, like, you have to hold it and then. Like.
Yeah, like here's one from calculator.net.
Got it?
It's like,
It's not like a paper, but. Google can even do it. How about you going to use this one? Or how about you just put it in for drain, that's the most happy.
nah.
See, I put in Google just standard deviation.
And there's a bunch. Like this is the first one on the list, I think was calculator.net.
So then you
Yeah.
put it in the box and hit calculate.
Make sure you pick sample on this one.
Oh.
Yeah, like this is the other one.
Yeah, please.
And it comes out to be the same thing.
Oh,
Like,
that one's fun.
so that's what I said. Find one that works well for you.
All right, so in this,
Ah, I got it.
so we're not doing, we're just doing the solid
I'll be
round,
ready.
solid number. We're not doing
I was popping up.
0.
Yeah, I did this. Well, 66 is 66.0. But when you get to 27.9, 26.8, you do have to put those in. The range is just 66 minus 25. So you subtract that, and that's the number. That's the range. Nope, you can say range equals that. Standard deviation equals that.
Cool.
So we put the number and then
Then the next number, yeah. You have to put a comma between.
I did solution and now
It's-
I don't know what this is.
And why we practice it.
Well, now that would be why.
Yeah, that wasn't-
I don't think I put
Now you have it.
So that's the only one we have to do in this portion?
That's, yeah.
That's the range.
that. Look, I want this to kiss.
And the range.
And then-
Don't forget the range.
Standard deviation.
All right.
And now type that.
Oh.
And you release standard deviation, it will just give you.
I don't
a-
like this one. I don't like this one.
All right.
I don't know.
All right.
And now we have to find the range to use this?
Yeah, that's literally subtracting 66 minus 25. So 13.00. No matter what, that's the standard deviation. Whatever one you decide to use, that's the standard deviation. And you only have one question with that, so it's not like you have to do it multiple times.
maybe I'm gonna use the phone ball for.
Look, I'm just trying to look at the app now, I just can't do it.
So, yeah, it's one question. You basically have to use the calculator. For now. Like I said, we're going to use standard deviation is going to be like a main theme going forward. The bell curve, those things, a main theme going forward. Oh yeah, you have to find standard deviation to do pretty much everything after this point. So, oh no, you don't need it for the rest of them. They're going to give it to you.
So the standard deviation.
13.0 because it said round to one place, so it's 13.0.
And the range is just.
66 minus 25, which 41. Yeah, that's the range.
Cool.
That's a hard question.
Right. No, but that was it. I want you to figure that out now or before next Tuesday, Monday's class. So this way, next Monday, you come in, it's like, boop, 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 done. So yes, really simple question. Really easy, 10 points. Yes, each question's worth 10 points. That's 100. No matter how many parts it has, each question's worth 10 points. So this question is worth 10 points, the same as the first question was worth 10 points. It had 4 or 5 parts. Okay. All right. Let's go on so we can get out of here at a decent time. Honestly, the rest of the questions aren't that bad. And that one wasn't bad. It was just making sure you figure out how to get your calculator and whatever, however you're going to do it done. All right. The rest of the questions is going to give you the standard deviation to do the stuff, so you do not need to find it again. All right, so number 7. Apply Chabesky's rule to solve. So quantitative data set has a mean of 25 and a standard deviation of 5. So it says 89% of the observations lie between, and at least what percentage of the observations lie between 15 and 35. To do this, write out basically that expanding chart of numbers. So we're going to put 25 in the middle, and then we're going to add and subtract 5. So one step out is going to be 30 to 20. The next one's going to be 15, 35, and then 10 and 40. So we've got 1 standard deviation I don't know, 2 standard deviations is 89%, and 2 standard deviations is 75%. Sorry. You use the empirical rule so much that it's like this.
Embedded, right?
Yeah, those numbers are literally embedded in my head. And that's 89%. So I'm like, no, it's close to 95. All right. So which numbers lie at least 89% of the observation is between 10 and 40. At what percentage 15 to 35 is 75%. That's it. Okay.
Just give us 2 of those.
So will there be an
You're not
example
A of
of
those.
this?
Huh?
There'll be an example possibly of this. But just
It's going to be the,
Yeah, A of
honestly, I think when I did that this problem and the next problem, they're exactly the same wording and everything. I just changed the 2 numbers. I just changed the mean and median. Yeah, that's literally all I changed. So, like I said, most of the problems, like if I could do that, that's all that's going to change. It's a couple of the numbers. So, because again, I want the practice test to be the stuff. So you figure out like, this is the stuff that's important. This is what you should have been able to get out of the first 3 chapters. It's like, this is stuff that you're going to need going forward. So I'm not trying to make this hard for you guys. It's like, I'm trying to make sure you learn and understand, but it's, like I said, if you do your work, you're going to pass. There's not an issue. And honestly, this question is going to be basically the same thing. It's just using the empirical rule. So you're going to do the exact same thing we just did. And it's the exact same numbers. So we've got 20 and 30, 15 and 35, and 10 and 40. So we've got one standard deviation is 68%, two standard deviations is 95%, and three standard deviations is 99.7%. So you do that out, and now we can answer our three questions. So 20 to 30, 15 to 35, and 10 to 40. That's it. So as long as you can get your app together, there's 30 points that are quite simple to get.
Like some of the expense work over here, I don't like some of it.
It's like, I don't want the 28. The 100 be nice. 28, no. All right. Copy that. All right. So they're giving you the exam score. They're giving you the standard deviation. It says compare the percentages of observations that lie within two standard deviations to either side of the mean that's given by the determinant control of K, or 2 and then 3. Remember, the 2 is 75%. The 3 is 89%. Okay. So if we just do our simple breakdown, so we have it. So we got 85. We add the 16.1, and we're going to get to basically over 100. So we're going to cap that out at 100 because that's the highest you can go. And then minus the 16.1 from the other side. So what's 85 minus 16.1? Thank you. I'm going to need more room. Hold on. 85, 100. 68.9? And then what? Let's subtract 16.1 again. One more time. 36.7. Okay. So 100, 100. It just keeps going 100. So that's one. That's 2. So that's 75%. And that's 3. So that's 89%. So the question is, oh, actually, this one does. I actually thought the question was different than it asked. Interpret what it is. So 75% of the students would score between 52, 53, and 100. And then 89% would score between 67 and 100. Probably should have read that question before I put it on there. That was simpler than I thought it was going to be. That's okay. So what are you up to? At least a 40? Without much thought? So it's like you're up to 40 without much thought. There you go. The other the sections do start to get a little harder when you actually have to do some more. The hardest part in stats isn't actually the calculation. The hardest part in stats is when we start getting to hypothesis testing and those type of things where you're actually having to make interpretations of the data and how it actually fits with the stuff. That's when it starts to get a little harder. But I try to make it as organized and as understanding as possible. So, all right, last one.
Wait,
Yeah, I got one more.
so the so for C, that the results were 52.8 and 100 and 30.
Oh, you didn't get a 10?
No.
Well, like, how did it not print 10? That's weird. That's weird.
Oh, okay. Like, how? Why did you need these?
So for
So you're gonna spend, basically, that question is, you're gonna interpret like we did before. So 75% of the students score between
52
this and this, yeah.
36.
89% score between that and that. That's it.
The answer for C.
Yeah, I actually, when I put that question on there, I thought the way I interpreted the question being asked was how they wanted you to look at the actual numbers and the points and see if it fit the 75 and the 89%. But it didn't ask that question. So that's, there you go.
Makes my life so much easier. But we can edit it.
Right?
Couldn't leave it like that.
So I'm not changing it. I've already made them. They're done.
We like it.
It's not happening. All right, last question. All right, last question is make a box and whisker plot from this. Literally the last question. So the first thing we have to do is put them in order, which is probably the hardest part of this question. Now, here is a suggestion for you. And I will have some blank sheets of paper because here's how I would do this problem. I would turn my paper sideways and I would write the numbers above. Okay? Because then you can literally make your box a whisker plot right underneath. So once you find the median, you draw a little line. Once you find the median, you draw a little line. So it's like you literally can just draw your box whisker plot right underneath the numbers. Okay? That's how I would do
Could
it.
be a lot of that.
Yes. So no, because I will give you a blank. I have blank sheets of paper, so I will give you another blank sheet of paper.
Yeah.
This way you don't have to keep going like this. Okay. Actually, because I haven't printed the test out, I will print an extra blank sheet of paper so it'll be stapled to the back. So this way you don't even have to worry about it. All right. I'm not going to take a time. We literally just did this a little bit ago. So I'm not going to take the time and actually go through and do this. You can do this one on your own. All right. But this is just organize the numbers out, draw your box and whisker plot. If you want, I will have it done on, give me till Wednesday. Because I have class again tomorrow night. So I'm not sure if I'm going to be able to get home and actually do it tomorrow night. So by Wednesday night, I will have up on my website I will have this up tomorrow. I'll have the actual blank test up tomorrow. I will have the actual test completely done, like written out and everything else. The answer key for it, including the box whisker plot and everything else, up on the actual website too. So you'll have the full the blank test and the answer sheet for it, so you can easily compare the stuff.
Both sides of the experience of the box, the fucker, the minimum, the maximum.
Right. It is the minimum maximum unless, and I think in this one, I'm almost sure you're going to have an outline, at least one outline. Because my guess is 21 is going to be enough.
So it would just be the next number.
Yes.
Okay.
Yeah.
Okay.
I'm because of like 21 and 70, that's like really low compared to some of the upper ones. So I'm going to guess in this one, you've got to have an outlier.
Okay.
So yeah, it'll just be whatever the outliers are, you'll be the one next to it. Okay. If you would like a blank copy to take home, I do have some more blank copies up here. You're more than welcome to grab them once they're gone. I picked out 28. So, not everybody. Like I said, I will post one online, so if you don't grab one, you can easily just download it.
How long do we have to take the exams? I'm gonna do it by hand.
The class, the whole class.
Oh.
The earlier you get done, though, the faster I get out of here. So
Yeah. Yeah.
and the happier I am with what I'm grading it. No, I'm just kidding.
There you go.
Have a good night, guys.
You too.
You too.
Thank you for changing the color.
Did that work better for you?
Oh, yeah.
Awesome.
Question. So every time I look at the website
Yep.
online, it only shows the syllabus.
It literally only shows the syllabus.
Yeah, it doesn't show anything.
That's weird. You pull it up, missing. Like that's weird. Because what should show up, at least for stats, is this
Okay, what is it called again?
Baker's math class.
Thank you.
You're welcome. You too. And then you should be able to click right on statistics.
Well, yeah.
So, like I said, look for an app that allows you to do it offline.
Oh, yeah, I'm gonna try.
Just like throw it on airplane mode, see if it works, and then you're good.
Yeah,
If not, I will have something here that you can still use.
oh, okay.
I am not going to have you do it out by hand.
Yeah,
Okay,
yeah.
I think I
You
found the
guys
problem.
got through two
You figured it out?
questions before I even got
Okay.
through it.
Thank you.
You're welcome. What's up?
Can I just ask about?
You can ask
I
about
just
anything
kinda,
on this section you'd like.
I just got lost on like what this question's asking me.
So A and B,
Uh,
it literally just wants you to look like, give me the range.
Oh,
Okay.
So if you do
52
this,
to
right.
100.
So if you do this right here,
Okay.
that qualifies for A and B.
Okay, great.
That I will look at, yep, you've got A and B.
And then
And C is just interpret the data. Like, what does it mean? Like, okay, here's the numbers, like these are exam scores. So 75% of the students score between a 53 and 100, basically.
Okay.
That's it.
All right, that's easy.
Yeah.
And then this last one, I gotta brush up on my quartiles.
So it's find the median,
Okay.
cuts it in half, and then find the median of the top and the bottom.
Oh, okay.
That's it. That's quartile 1 and quartile 3.
Okay.
And you're done. That's literally it. And then the min and max. The only thing you have to do with this is the hard part of this one actually isn't the quartiles. It's doing the interquartile range to find out if there's any outliers
Okay.
when you make the box plot.
Okay.
Okay.
All right. Thank you.
You're welcome.